Okay, so let's move on to the second speaker. Thank you, Michael. So let's move on to the second speaker. This is a completely different topic. The second speaker is Krzysztof Wroblweski, who's the CEO of the Polish pyrolysis operator Contec. And Krzysztof's presentation title is The Way to Circularity in the Automotive Industry. So, Krzysztof, please take the stage. Thank you. Sorry? Yeah. Yes, you can. Yeah, of course. Yeah.
So, thank you very much for a kind introduction. As you heard, my name is Krzysztof Wroblweski. I'm CEO and CTO of Contec, and I will take you for the journey about pyrolysis and what we can do to improve the circularity in the tire industry. Okay, but maybe you didn't heard about Contec, what we do. We are the operator of 2 pyrolysis lines, and we have running for several years technology demonstrator, which has the capacity for 12,000 tons of end-of-life tires per year. The plant is located in Szczecin. It's near the German border, northwestern part of Poland. And we are a unique technology developer. We didn't bought our reactors somewhere else in Asia. We developed the technology from scratch, and we are the only one in the world using molten salt as a heat transfer medium, which brings certain advantages. But I don't want to get very technical, because this is also retreading business conference. That's why I will try to be as broad as I can, so everybody can take something from this. But R&D started in 2014, and we designed the plant throughout the years, and the pilot plant is in operation for more than four years right now. And we completed the fundraising round for 15 million euro to further expand our capacity. And the project is in schedule and in budget, hopefully, and will be starting first half of next year. New locations are in evaluation, so we'll scale out the capacity further down the road in Europe. But if you can imagine, and even today, if you go to one of these halls here at Future Motive Conference, you'll see a Michelin tire, and this Michelin tire is made from 68% of sustainable raw materials. It's a demo tire. And with all these existing technologies that we have really right now, we can easily match 30% of sustainable raw materials as an input for the tire. The only issue right now is the scale and the availability of all these resources. So we can go with circular steel from tire shredding. We can go with circular RCB, and I will tell you something more about that in a minute. We can go to circular sustainable virgin carbon black. I'm pretty sure you know carbon black itself, but you can make this carbon black from different feedstocks. And usually it's being made from very nasty fossil oils, but you can make it circular if you use tire pyrolysis oil as a feedstock. And this is being done right now. And also you can use circular rubber powder, because everything that can be mechanically recycled should be mechanically recycled. But here I represent chemical recycling, and this is second step for the recycling. And I will tell you about 6 very important things how to make it really feasible in terms of chemical recycling. So what recovered carbon black industry needs to succeed in bringing circularity in the tire and rubber industry. So let's go with this. I have 6 points, and I hope you will stay with me for all the 6 points. So the first one is operational excellence. Usually pyrolysis companies are very small companies. We are technology developers, and then we try to validate the technology, and barely some of them in the world gets to the point where we have actually running industrial plant and have some operational excellence. So proper design, safety protocols, team training, process control are essential, and maintenance as well are essential to turn the idea into industry. So the whole organization changes. Right now in Contec we have like 70 people, and most of them are running the process, and this is not R&D anymore. The second part is about actually quality and R&D, because recovered carbon black industry is being still under development. We just try to find new methods how to characterize recovered carbon black to be sure that we can put it back to tires. And this is being done. Contec is already accepted by major tire manufacturers for their feedstock and inliner applications. So this is working, but it can be done only when you have R&D team and quality control team in stock. And even if you have team, you also need the laboratory, of course, because you need to invest in laboratory to measure all of this data and all of these parameters in-house, because if you don't have in-house laboratory, you will outsource everything and you will wait months for the results, so you will have no contracts. So you need to change all the business around this from being technology developer to actually producing something, yeah? And also, this is something different if you have R&D, and also something different if you need to have response and quality assurance procedures, because tire manufacturers are being really used to somebody who has like 200 people in the quality department and all the certifications. The small companies that really takes care about the pyrolysis right now, they don't. We are one of the first one actually to build quality schemes in Raw, and there are like 5 or 6 companies that have ISO certification for the quality. So this is still a challenge for pyrolysis industry, but we'll do it. And the third thing is about auxiliary technologies, because I'm sure most of you that really know pyrolysis knows it for, I don't know, 10 years, 15 years, but the quality was not there. And not only the quality was not there, but there was no auxiliary technologies that could bring this recovered carbon black back to tire, because first you need to mill it, then you need to pelletize it, and there were no actual providers of technologies that could reliably do it for you. That's why it's really needed by the industry that these all auxiliary technologies, shredding, milling, pelletizing, drying, are being developed, so we can go with higher capacities, with lower maintenance costs and higher safety solutions as well. So also, apart from just being purely operational, there are quality standards. Like I said, we are just developing the methods how to characterize our products, because they are so new. And there's huge progress in ASTM D36 committee, which we're working on to characterize end-of-life tire products, tire pyrolysis oil, and recovered carbon black as well. The fourth thing is the feedstock control. I think it's something that can be copied in all businesses, because if you put garbage in, you will have garbage out. So feedstock control is very important. And because of the change of how tires are being manufactured, we'll have the change in what are the products of the pyrolysis itself. Because I'm sure you know, when you're in tire business, tire manufacturers are putting more and more silica in the tread itself because of development of functionalized SBRs. And we made a test. So normally when we use end-of-life tires, mostly PCRs in our operations, we have like 25% of ash content in RCB. But because of the silica content increase in the tread, when we pyrolyzed new tires that didn't meet quality control from tire manufacturer, we've seen the ash content for 35%. So we ask tire manufacturers, how do you want us to make lower ash content in a recovered carbon black when you put so much silica in the tread? It's just impossible. But nothing is impossible. We find a solution for that, but I will tell you in a second. But this will be a long-term trend in European Union, and we'll see that average ash content will rise during next few years. So it's really difficult to get the contracts when you said, okay, in specification we have 25%, but we expect that in 2 years from now we'll have like 28, and maybe in 6 years from now, because those tires are already on the road, I will have like 30 something. So this is something really difficult. And this also influences in rubber performance of recovered carbon black, because right now we are easily in the N660 range, so we are okay to be put in sidewall or inner liner compounding. but not in the thread. But if you have much more silica, it will be difficult for the sidewall to get involved. So what are the possible solutions? Of course, if you put more TBRs, there are less silica in the thread, so you could push your pyrolysis with more TBRs, but TBRs should be retreaded. You're all talking about that today, so this is the right way to go with TBRs. Of course, we can try to separate the minerals out of RCB, but this is dangerous and very not cost effective. But we chose different approach. So we went to sidewall and carcass specific pyrolysis with our partners. We partner with Tyre Recycling Solutions, a Swiss company, which takes the tires, cut it, the sidewall off, and then they use their own technology, which is called TRS water pools, to shave off the thread with water jetting, basically, to micronize and to create some kind of powder. This powder is called Tyrexol and can be used directly by tire manufacturers in new threads, maybe also for retreading. I highly encourage you to approach them if you're making compounds for retreading as well. But there is sidewall and carcass left, so we can use it. And we did pyrolysis with very specific feedstock from them, just the pure sidewalls, and we had really great results with resulting RCB with lower silica content, high reinforcement, and really good results. What else is needed? The number 5 is market traction, because most of small companies have no cash flow for high capex, and if you want to sell recovered carbon black, and you can see carbon black at the lower part of the image, you need to invest a lot in the so-called RCB finishing line, and this is really difficult, because on one hand you have substantial demand, because every tire manufacturer right now is going to chase you after recovered carbon black, because there's not enough in the market, the prices are high, but on the other side it's really significant capex, and it takes almost 1.5 years to build a proper finishing line, like we have one in Szczecin. So at the end, this number 6 point is sustainable business, because it was extremely difficult that year and previous year to get financing for this type of industry for scale up, and we need to work together. I believe the collaboration is the way to go. So we need economy of scaling in chemical recycling. That plastic pyrolysis is leading the way, because everybody right now from the plastic industry and plastic pyrolysis industry is expecting that the off-takers will pay higher prices just to develop the capacities for the pyrolysis industry. So there are several things to consider, and we need clear guidelines as well for LCA, because everybody is presenting, like we do present for recovered carbon black, that the carbon footprint is much lower, but everybody is calculating this in a different way. So most probably you are also asked about what is the carbon footprint of retreaded tire and how to calculate this. We need really clear guidelines for LCA studies and the carbon footprint, and we are already doing this in task group in Chemical Recycling Europe, so this is being done. I will not talk too much about all these points, because I think my time is running off, but I told you already about the fundraising from completed, so we're very happy with that part, and this will increase the plant's capacity. So we'll hear more about Contec in the future, and I think I have a call to action for everybody involved in the tire manufacturing industry. I think we should share this call with retreading industry, that we need expressed demand, because each declared kilotons of RCB or your products really matters. If the tire manufacturer is saying loudly and publicly they want to buy it, it's much easier to get financing, because venture capital and private equity investors are not the insiders of sustainable raw materials business. So it's not that very easy to assess these cases for them. So what also we need in terms of recovered carbon black is really industrial volumes, and this is ultimate goal, because We right now produce several thousand tons of recovered carbon black per year. When we approach tire manufacturer, they want to start with 5,000 tons per year just for one plant. And we are, too small for them and too big for different players that we need to invest and scale up. That's why I think this kind of collaboration that I told you about is a must. So you can meet us offline. We're all invited to visit us at our plant in Szczecin. And you can meet us online as well. Find my LinkedIn. Thank you very much for attention.
Has anybody got any questions for Krzysztof about the pyrolysis sector before we move on? You're all very quiet out there. Are you sure you haven't got any questions? Oh, there we go. John.
Krzysztof, just a thing, the retreading. Do you see that you can actually use the RCB in pre-cure threads or mold-cure threads, or will it only go in sidewalls?
Yes and no. Right now, I don't think so. The main goal for recovered carbon black right now would be sidewall and inner liner because it's much easier, and the RCB mostly behaves as an N660 in most applications. But on the other hand, there are R&D going on about the activation of recovered carbon black, and we see first promising results to activate recovered carbon black to get it more, I would say, reinforcing. And if it's more reinforcing, it can be added in thread, because usually in thread you use N330 and more reinforcing grades of virgin carbon black.
Thank you. Just one more question is, what happens if silica content starts going up in the threads? Do you see that going to be an issue on the quality of the RCB that will come out?
Of course it will be, because we can see that silica after pyrolysis is not active at all. That's why the reinforcement will drop. Therefore, we try to find a solution, and one of this is our collaboration with Tyre Recycling Solutions to shave off the thread and make it pulverized, and then pyrolyze the rest of the tire, because it will guarantee that the stability of the feedstock. Yeah. Because in the carcass and sidewall there is much less silica content, and the variability of, generally speaking, minerals in those parts of tires is much, much lower.
Thank you.
Thank you very much. Oh, one more question here.
Thank you. Just a short question. Sorry, in pyrolysis process, typically there are three kinds of output. There is gas, which is used to feed the process. There is carbon, which is your raw material. And then there is oil. What do you do with oil?
Okay, so oil, as I said, could be also circular. And we have several applications for the oil. The easiest one, of course, is industrial heating, because it's very calorific, but this is not recycling. If you use something for energy purposes, it's not recycling. Therefore, we work with global manufacturers of tire processing oils, so we can use mass balance approach to use tire pyrolysis oil as their feedstock for the refineries, and then try to make tire pyrolysis or tire processing oils for the manufacturers. The other application would be to make sustainable virgin carbon black. So instead of fossil feedstock, you could use tire pyrolysis oil by Orion, Cabot, Birla, or whatever who produce virgin carbon black as a feedstock for the furnace. And then you create sustainable virgin carbon black, which is exactly the same in terms of parameters as virgin. So it can be used in the thread, for example, but it's with much lower carbon footprint, and it's circular because it's made from the oil made from tires. Okay?
Okay, and any other questions before we move on? No? Okay, well, I'm sure there'll be time later for further questions. Thank you very much, Krzysztof.
Thank you very much.
For a very clear description of the dynamics of the pyrolysis sector. Thank you very much.
Thank you very much. If you
Okay, so our third speaker today has come from Canada, and that is John Visaisouk from Tyromer. Now, John's company is in the devulcanization sector, and when I talked earlier about crossover topics, John's company is, of course, in the tire recycling sector, but he's going to talk about today about moving towards tire-to-tire recycling, reality of circular retreading, and he's going to talk about the application of his company's devulcanization process into a circular retreading concept. John.
Thanks very much, David. Really appreciate it. All right. Hi, everybody. Thank you for having me today. Thanks, David, for organizing this. So, you know, a lot of this stuff in the last presentation is actually quite relevant to our technology as well, to devulcanization. And I think it shows that, you know, despite whatever type of technology it is, the recycling sector in general really needs our support right now. And so today I'd like to talk to you about the future of tire recycling and retreading. For us, that means tire-to-tire recycling through our concept of circular retreading. Now, what I call circular retreading, basically using the retread buffing dust or the retread waste as feedstock for pre-cure and mold cure retreads. And we do this through our process called devulcanization. And so really in this method, we're taking the retread buffing, the retread waste, and turning it right back into new retread material. And so I'm going to describe the steps to go through this. It's quite straightforward in the sense that we don't change anything of the first step of retreading. So you look at standard truck, bus, OTR retreading. The tires are buffed down, meaning the old tread is removed from the tire for the most part, and so a new tread can be glued on or molded on. But we really use this buffing dust as our feedstock. Now, I'd like to make it clear that the devulcanization technology works with a large amount of feedstocks. Basically, any material that's been cured with sulfur, we have the potential to devulcanize. But for this particular presentation, we're talking about retread buffing and again, circular retreading. So step 2 is really the devulcanization step. So after you have this retread buffing waste, it goes through our clean process of devulcanization. So basically, we're using a twin screw extruder. It's a thermomechanic reaction. We actually do not use any chemicals at all. And so it's just the retread buffing waste that goes into the machine. And it's this, we call it tire-derived polymer, or TDP, that comes out. Again, there's no chemicals used in our process. There's no additives. Now, this is a really old video. This is a 10-year-old video. You can see the chrome rubber falling into the extruder in the middle there. I like to use this video because it really shows the simplicity of the technology. Like, that was the chrome rubber going in, and this is the devulcanized rubber coming out. And that's the whole manufacturing process right there. It's a really simple process. Now, since here, this was about 10 years ago, since then, we've really developed a lot of downstream processing, like automatic packaging, metal detection, weighing and cutting. But the actual devulcanization process, that was it. The chrome rubber goes in, it's a thermomechanic reaction, and this devulcanized rubber is what comes out. Now, step 3, once we have this devulcanized rubber, what do we do with it? Well, we take it and we mix it into a rubber compound. And so this could be a mold cure, this could be a pre-cured tread. It's also important to note that our material, because it comes from basically the retreaded tires, it inherently contains about 26–27% recycled carbon black. So while we talk about our material being recycled rubber, it's really a recycled rubber compound that contains natural rubber, synthetic rubber, and carbon black. And so again, just using our material, carbon black as a filler, it's really the vulcanized rubber that gets in the way of reusing that carbon black. And so by devulcanizing the rubber, it makes it a lot easier to mix in. And so again, our material is inherently about 26 or 27% recovered carbon black. Now from there, we mix it into a retread compound. Again, this could be a pre-cured compound, this could be a mold cure. In this case here in this picture, this is a mold cure compound. And so in terms of the addition level, we look to add maybe 10, 20, or even 30% recycled content into a new retread. And it really depends on the application, but still that's the potential here, is using 10, 20, or even 30% recycled content in a quality retread that meets the industry standards. And so for the application of it, this is for mold curing. And so this was actually the first big application that our TDP was used in Canada. And so there's a big company called Tyre. They do a lot of mining services. They've been a partner of ours, and they've been using this OTR retread compound for about 6 years now. And so they started with 18%, using 18% recycled content. And just this year, they were actually able to increase the recipe to 25% recycled content. So these tires that you see here, these are newly retreaded OTR tires with 25% recycled content in them. And the recycled content is the rubber compound, basically the rubber and carbon black mixture. Now, we're doing the same thing for pre-cured tread. I'd say the development is maybe just a little bit behind it because this is just starting to come out now. But these are basically, it's the exact same method and process. So basically, you're making this pre-cured compound. Again, 10, 20, 30% recycled compound. But for this application, for a pre-cured truck tire tread, we're looking at more at that 15% range is probably right now more the optimal level. As the tires get larger, we seem to be able to add a little bit more recycled content into it. But for a pre-cured truck tread, we should be targeting 15% recycled rubber compound right now, because this is basically what we've been doing the last few years. Again, I think a lot of the comments that Krzysztof made in the last presentation make a lot of sense, because us too, we have been working very closely the last few years in quality control, controlling the feedstock, opening up the market. So again, these concepts are not just related to our technology, but to the tire recycling industry in general. And I think, of course, events like this are great to bring more attention to it and to bring the right minds together. Now, again, this is something that we've been doing in Canada since about 2016. And so we can say now over about 15,000 OTR retreads have been made with this compound with 20% recycled material in it. So this is something, again, we've quietly been doing this in Canada, but it's been ongoing for about the past 6-7 years now. And so, again, we've passed about 15,000 OTR retreads with about 20% recycled material content. So a little bit more about this tire-derived polymer. So again, it can really be made from basically any rubber material that's been cured with sulfur. So our most standard is retread buffing. We started with retread buffing because it's very finite. The truck TBR, retread buffing specifically, very finite in terms of the composition. It's pretty standard whether you look at the truck tire composition of Europe to North America, even to Asia, they're relatively similar. So we liked retread buffing because it gave us a very narrow range to start with. From there, we've really standardized whole truck tires. So we have a whole truck tire product. We can also do a whole passenger tire product, but it's a little bit lower quality. So right now, our main sources of feedstock will be 1, the retread buffing dust, 2, end-of-life whole truck tires, and 3, end-of-life OTR and giant mining tires. Those are actually incredibly, very lots of, great amount of recycled rubber in those big tires potentially. But we can also do factory scrap, we can do factory reject tires. The technology has the potential to devulcanize other synthetic materials like EPDM. But again, right now we're really focusing on the retreading. And this is actually, again, the longest standing application that we've been into. Now, as Krzysztof was mentioning earlier, it is very important to control the feedstock. To be able to supply the tire industry and the tier 1 manufacturers, you really need to have your QA and QC in order. So, we have ISO 9001, the 2015, the ISO 14001, and these are really just the start. Now, benefits of using tire-derived polymer, well, we think it really significantly reduces the CO2 impact or footprint. So if you make TDP instead of making a new tire compound, you will save about 90% of the energy. The devulcanization process is quite simple, as you guys saw. It doesn't have chemicals added, no additives, and the energy efficient process uses about 300 kilowatt hours per metric ton produced. Now, TDP can be basically always sold at a discount compared to natural rubber or carbon black or something like that. So it definitely will reduce costs. We like it because we prefer to produce this locally. So the whole point of our technology is to license the technology and get it out there to where it's needed. So if we need this in Italy, we want to put a facility in Italy. If we need this in Australia, we want to put a facility in Australia. The point is to use local material and have a local source. You can use those local tires basically as a local source of rubber. And so in places like the United States and Europe, where we do not grow rubber, we can still have a source that is largely natural rubber coming from these end-of-life tires. And as I said, this TDP is actually currently already being used in these applications. So it is being used in new passenger tires right now. It's being used in retreaded truck tires. That's pre-cured. It is being used in OTR retreads as mold cure. And it's actually also being used in some conveyor belt applications. And so it's really a versatile material. It has a lot of potential in it. And right now we're just trying to get the word out and let people know that this is possible. Now, beyond just regular tires and retreading, just as a quick thing to show, the material can be made, into a lot of different parts. So these are example parts that are made with 100% recycled material. These ones up here are made out of whole truck tires. So again, the material has a lot of potential. These are some more products made with portions of TDP being used. And so again, we really think it's a versatile material, but in this case, retreading is really where we think we can make the biggest difference quickly. And so just a little bit about Tyromer Inc. As David said, we're a Canadian company, so we're founded outside of Toronto, so in Waterloo, Ontario, about an hour west of Toronto. We are a licensing company, so we want to license the technology. We don't want to be setting up and running all these facilities ourselves. We want to be capitalizing on the strengths of partners and being able to keep on our own technical expertise. We're really a technology company, so we like to continue to develop the technology, find ways to increase the properties, find ways to make the process more stable. Right now we have 2 facilities in Canada. We have a facility in Arnhem in the Netherlands. There's a facility coming to Chennai, India next year. Early next year, and there's a few more in the planning stages. So hopefully we have something else in the United States and an additional one in Europe coming soon. In this for this audience, I thought it was important to kind of mention what can people do to help right now. And again, I think a lot of the points Krzysztof made were really spot on in terms of the support that we're looking for. And so, for individuals, we want the consumers to start requesting recycled material from the tire manufacturers. That will eventually start to change the way that they work. If their customers are demanding it, then eventually they will change. So that's something that can happen. So individuals, consumers can do this. If you're a fleet manager, that's a perfect job. That's a perfect thing for you to be able to root for. We think local jurisdictions can promote recycling more via grants, startup programs, direct subsidies, things like that. Large-scale government, and we think this is coming here in Europe relatively soon. There will be legislation, I'm sure, for using more recycled rubber in products like tires and retreads. As soon as it becomes basically doable in the market, which it is now, so as soon as the market supply is there, we believe this will be coming. So in the next few years, we expect there to be recycled rubber mandates coming in multiple jurisdictions. I like to use an example of the Renewable Fuels Act in the United States. It was actually one single state of Minnesota that started the Renewable Fuels Act. All the big companies, Ford, GM, they said they couldn't do it, but they passed it anyways, and now basically 15% of all the gas you buy in the US or North America is like ethanol or kind of the recycled, the green material. So it is definitely a kind of a path that we can follow there. And private industry, we really want to accelerate the development. I think that the potential and the proof of concept has basically been proven. And so now we're looking to basically create this supply where we can actually supply the tire industry in large levels. And so we want to accelerate recycled rubber compound development and in terms of usage and application. And so we want to take the first steps today, so in the future we are running with it. And this is just a small tour of our facility in the Netherlands. This is in Arnhem, the Netherlands, so a couple hours outside of Amsterdam. So it's on a clean tech campus, but this is our Tyromer Europe production facility. We call this kind of our facility 2.0. This really is it's really a showcase facility. It's not a true manufacturing facility. This is really a place where we want to bring people, show the technology off, get people comfortable, and provide material as much as we can. But really, it's a showcase facility. We do have 2 ISO certifications. We have a full straining capability, which is basically forcing the hot rubber through a fine mesh screen to remove any contaminants. We have metal detection as well. Full QA QC lab. We actually have 2 extruders here. So we have our main extruder, the 90, is for our standard tire material. We have a smaller extruder, the 60 millimeter, which is good for synthetics, specifically things like EPDM. Again, we have this full straining capability. This is really important. I don't want to brush past this point. This is really important for quality in the tire industry. So basically, as you go through the crumbing process or as you get the retread buffing dust, there will be a little bit of contamination, whether it be some metal or wood or stones. There's going to be something in it. So basically, we force the hot rubber through a very fine mesh screen to remove any of those contaminations. This is a really important point for breaking into the mainstream tire industry and tier 1 manufacturers. So while we are doing this in all our operations now, we believe that basically any recycled rubber going forward is going to need to have some kind of straining mechanism or some kind of quality standard such as this straining. So we have automatic cooling, drying, and cutting. So basically we'll go through a metal detector. It'll weigh out exactly a 10 kilo sheet plus or minus a couple of percent, and then it'll automatically stack the material. We check for metal. This is very important. So there's metal checks at the beginning and magnets through the system, but this is one very final check before we stack the material. We check it for metal one last time. Again, quality and tire industry go hand in hand, and so this is something that we've had to spend a lot of time on in the last few years. Again, full QA and QC lab. So like any other product, if you order from us, it comes with a certificate of analysis. We can agree on whatever specifications we want to together, but we have the full lab to provide it as well. And so in conclusion here, really, this concept of circular retreading, it's not just a concept. This is actually happening right now. We're doing this right now, and we feel like we can do this a lot more. I think the support in Europe is particularly good for these kind of activities. Retreading can really make a difference. We've seen that, and now this kind of takes it a step further by using the own retread waste to go back right into these retreads. And so again, as a licensor of technology, we would love to continue to discuss with partners. So if you have a need for material, if you're interested to learn more, please come and talk to me. Thank you.
Thank you very much, John. Much appreciated. Has anybody got any questions for John? Please. Yeah? Yep. Sure. Okay.
Thank you. Yeah. Hi. Good afternoon, John. What is the approximative amount of investment that's required to set up one of your factories? And what is the volume of production required to reach the break-even?
So our standard facility, our standard machine would be about 4,000 metric tons a year. And, give or take, depending on what you need for downstream, I'd say your price is around 3 million USD Again, I can discuss specifics with you, but that's a good ballpark to use. Welcome.
Anybody else? Nobody else at the moment? Okay, at this point then, thank you very much, John. Appreciate it. Thank you. Well, we're well ahead of schedule at the moment. We're now moving on to our final presentation. We have two presenters here who will both come to the stage at certain points during the presentation. We have John Powath from IBP and Brian O'Connell, who is the Chief Commercialisation Officer for Silpara Technologies. Now, this is also a presentation which will be of interest to both to the recycling sector and to the retreading sector. The title is Affordable Sustainability, and it's about the latest developments in reducing operating costs as part of a sustainability program. So I believe Brian is going to start, right? Yeah, okay.
Good afternoon, everyone. Thank you for your attention, and thank you for your time today. Time is our most precious asset, and I appreciate that the greatest. It's always fantastic to be the last one up in the last presentation before a party. So hopefully you'll find the presentation worth your while. So as David said, my name is Brian O'Connell. I am from Silpara Technologies. And we're a startup company, not unlike a number of the companies that have already been up here. We are pre-seed stage, and what we're going to talk about today is how to create, or really come to grips with how to make sustainability affordable, because we have some lessons learned. And to preface the discussion, I just want to be clear that I'm not an economist. I am not a sustainability expert. What I am is I'm a business leader who really faces a lot of the same challenges that those of us in the rest of us in the room face, which is how do we get the global economy to pay for our efforts in sustainability? It's one of the things that we've become very clear to us as we've gone on our journey, is that sustainability does come at a cost. And that cost can be, or the price tag can be, a lot larger than what we're willing to pay. And so what we did was we went back and we kind of took a look at, I tried to be as global as possible, so I use an example from the United Nations. The United Nations has their Sustainable Development Goals, and they publish their Sustainable Development Goals every year. In 2023, in September of this year, they came up with a cost to achieve their 17 stated sustainability goals was roughly $195 trillion. That's trillion with a T. That's an enormous number. It's more than the gross domestic product of the 5 largest economies in this world looking out 15 years. It's an immense number. And that number has gone up by $20 trillion in the last 2 years, or in the last year over year. And the reason for that is, number one, it's the sustainability goals are being underfunded. People are not paying for those goals. Number two, the shortened timing. People are saying that we need to get to those sustainability goals in a shorter time frame. Number three is inflation. Obviously, inflation has been something that has affected all of us, so the cost of every good is going up. And then you have rising net zero cost. There are costs to everything. The technologies that we've witnessed here today cost money. The technologies that we need to implement to achieve net sustainability, those costs have gone up. And then the final item that I put on here is carbon offset. There are a lot of very large organizations who may or may not pay for their sustainability in real innovation or in real technological development. What they will do is they will pay for a carbon offset, and they will allow themselves to claim that they are at a sustainable level. Looking at this and where we fit in as an industry as well as individual companies, we know that roughly 40% of the costs that $195 trillion, they estimate that 40% of those costs must be taken care of by innovation and technology. So technology has to step up and mitigate up to 40% of that cost. How is that going to happen without it being paid for? If we look at sustainability, people ask, well, what is sustainability? Sustainability can mean a lot of things. Sustainability can mean you're going to pick up the litter that one of your colleagues may have left on the floor. Sustainability could mean that you're going to take a bus instead of drive, take a train instead of fly. Sustainability means a lot of different things. What we consider to be, or what I've considered to be the circle of sustainability, is really our ability to maintain a process continuously over time. So you can't put small stopgap measures in place in order to reach sustainability. You have to be consistent. What does it mean as far as we're concerned? I like to use three distinct areas. You've got your people, you've got your planet, and then you've got your profit. None of us are in here to lose money today. We're all in here because we need to eat and we need to sustain our families, we need to sustain our lifestyle. So in order for the people, i.e. the human effects of the economic system to remain sustainable, we've got to make sure, and in order for the planet, and for us to support the life systems on the planet, we've got to make a profit. A profit has to be generated. We cannot forget that. People have to be willing to pay for this. So what is the reality? What is the cold, hard reality? The cold, hard reality is there are many examples of failed ideas where people, either due to lack of affordability or lack of ability to pay, that the concept either seems out of reach or is subject to failure. We've seen a number of organizations here today who are at startup level. They're looking to gain funding. I congratulate the funding that you've received. It's a very hard thing to raise 15 million euros. You know that. I've been working on it for 5 years now. So it's an extremely hard thing to gain someone's trust that you're going to do what you say you're going to do and reach the goals that you say you're going to go out and achieve. So that concept and the reality that we have is we have to make our technologies affordable. We have to make our technologies available. So what is our focus? Our focus at Silpara is to basically introduce a sustainable technology into a 135-year-old industry. That also has to increase performance at a cost that the suppliers, the users, and the producers and the end users will accept. It's an extremely difficult thing to do. And as all of you who have been in this industry a lot longer than I have, you know, I heard someone say earlier the industry at the OE level acts pretty slow. There's no doubt about it that the industry is not a fast industry to adopt. And so our focus and our challenge as an organization, as we've discovered, is to change a 135-year entrenched industry, which is extremely difficult. So when it comes to affordable sustainability and pricing, a lot of the conversations that I've had with folks this week, as well as in the 5 or 6 years that we've been doing what we do, is how much is it going to cost? What is your price? I understand and I appreciate downstream what the savings are going to be. I understand and appreciate upstream what your commodity costs are. What's it going to cost me today? And my question to them is, what are you willing to pay for sustainability? Most people reach into their pocket and say, well, the spare change that I might have. They're not going to pay 50% more. They're not going to pay 30% more. They're not going to pay, even in some industries, 1% more. A lot of the industries that we see today going to single-use tires. Single-use tires may or may not be the way that the companies are able to afford putting tires on their vehicles. So single-use tires are going to go after the retread industry in a big way. I know in the North American space, that's the biggest problem that they have in the retread industry today from a product implementation perspective is single-use. So how do we get around the affordability question with, you know, a circular economy and sustaining a circular economy when you have other factors that are trying to put you out of business. Scale. We talked, some folks talked about scale today. From source to channel. How do we make sure that those conservative first and second adopters are going to take you in and say, yes, you're a good sustainable option for us and you're affordable for us. We need to have that in the back of our minds. Raw materials, obviously the recycling cost of the infrastructure, the fact that there is a lack of a circular economy today. We've been talking about circular economies. We've heard it this afternoon. That circular economy doesn't really exist. It's very, very disjointed and it's disassembled. And so we have a very large challenge in the industry with that. There are certifications that need to go in place, extensive testing up front and on the back end as well. And as some of my counterparts have also said here this afternoon, lack of a specific regulation and getting a regulation passed. How many years? 7? 9? Okay. Sorry to bring up a painful point. But as we can see, lack of regulation. I know in some instances here I feel like I'm preaching to the choir, but let's talk about reality. There is a reality. People have to be willing to pay. So the large players, they have a lot of internal momentum. They're not going to give you the time of day unless you're coming in and you're offering them 50% cost reduction and better performance. Let's face it. Everyone has a KPI that says, I'm going to save 10% in my cost this year. And then at the end of the day, the slow adoption rate, and we talked a little bit of that on the practice. So we have many trade-offs, and the trade-offs are numerous. I won't go through these individually, but you can see them in the presentation. In order to get from your price in the performance, to get to the sustainability, how do you break those trade-offs? How do you go through and get true innovation that breaks those trade-offs? So what we're going to talk about briefly, I will turn it over to John here in just a little bit. We're going to talk about case study and tire performance. And what we're going to focus on is, you know, there are 5 major sections in regards to where the tire industry is committed to going to a net neutral carbon neutrality, or net neutrality and carbon reduction by 2050. Of this net reduction, the tires represent 15%. 15% of the global tire carbon neutrality is going to come from the fuel efficiency of the tires themselves, as well as from the reclamation of those same. The industrial operations are one part of it, the logistics, supplier compliance, but product energy efficiency with the non-tailpipe emissions, as well as through the rolling resistance. Those are the keys. So hopefully we all know the magic triangle. We used magic quadrangle. The magic quadrangle for us is to expand that envelope from 1 to 1+. And to do that at a rate that is going to be just as affordable as the product that you have today, if not get some value for that product based on the fact that you have a better performance. So we know in our particular case, we're trying to mix silica with natural rubber. That's been the probably hardest technical barrier for truck and bus tires achieving next level abrasion and rolling resistance performance. I think that could be agreed upon. At least 98% of the folks that we've spoken to and gone to the industry for have told us that that is going to be their biggest issue. So what we're trying to do is get silica and natural rubber to play well together. And in order to do that, what we've done is we've created a drop-in process. Does not require any type of a reactor to do. It is mixed basically at the source of the natural rubber in the plantation, and requires much less water. John's going to talk about this, but it requires much less water to produce. As a matter of fact, folks may or may not know this, but in order to coagulate and dry natural rubber into sheets, each kilo requires 15 liters of water. Our process will take 15 liters of water out of the process. We'll save the water on the back end. And then as far as the product performance is concerned, we have been able to reach, in certain formulations, we're at parity with rolling resistance. Some formulations were a little bit higher in rolling resistance, up to maybe 20–25%. We're going after the abrasion resistance, which is going to increase the wear component, and our hot tear numbers are looking very, very good. And then as we focus on wet traction, we want to make sure we're at parity. We're not giving anything up to the customer. So this is the last slide I will talk to, and I will turn it over to John. But from an overall savings perspective, what we're expecting to get and get paid for, we're not going to get paid for it the traditional way. We're going to get paid for it through performance. Our solution provides a little bit of an innovation, or a lot of innovation, when it comes to the problem that we've gone out to focus on. And you can look at the numbers there. It's a gigantic opportunity for the industry to go after. Looking at it from front to back in the ecosystem has been our approach. John's going to talk a little bit about the savings that we're looking at and where we're going at from an environmental perspective. But hopefully at the end of the day, what you've taken away here is that as an industry, we've got to innovate. We can't greenwash. We've got to go after real problems and solve them with real technology. I thank you for your time. I'll turn it over to John.
Good evening to all. I'm going to be very short and sweet, not more than 3 slides. So everybody in the room is aware about tires. We know how to manage the process. We all talk about carbon footprint. But have we at any point of time stopped and said, what is more important? Is it carbon footprint or water footprint? So these are some numbers that you would know. The production of natural rubber, 14 million metric tons. I'll just correct what Brian said. In the entire process of making 1 kg of RSS or block rubber, we would be using conservatively 25 liters of water. That's the entire process. You have to wash the plates, put everything into place. So if we assume out of the 14 million metric tons, if 10 million goes for the tire industry in form of block or RSS, we would be consuming 250 billion liters of water. Now, that looks like, what is 250 billion liters of water? Just to give you an idea, a pictorial description, 1 billion liters of water is equal to a small lake. So every year, we throw 250 lakes out just in tire production. That means when we are creating the natural rubber. Now, what if you can save 250 billion liters of water? That is going to be a game changer. So the whole process, when the Silpara sheets are manufactured, there is no external water used. You take the water that's there in the latex and let that dry. Now that is what is going to be a game changer. Most of the time, companies come and say, we have these sustainable goals, nice writings on the wall, but zero action on ground. This is where you can actually put action on ground. So the question is, will the consumers, will the end users say, yes, I want a sustainable product? Now, the beauty about the product that Silpara has is it's not going to cost more. As Brian said, it's affordable sustainability. That means you will start saving money. And very simply, for every tire, retread that you use, you'll save about $1,000, over the life of the tire. And that is equal to actually buying a new tire. So besides just saving money, you can actually be sustainable on the carbon footprint side, and more importantly, on the water side.
Water. It's one of our most precious resources, but our water supplies are limited. 97.5% of the Earth's water is salty, and only 2.5% is fresh water. But over 2/3 of this fresh water is locked in the polar ice caps and glaciers. This leaves only 0.5% in our lakes, rivers and groundwater for agricultural, industrial and personal use. But due to pollution, the quality of this water is under threat. According to the World Health Organization, only 0.007% of the world's total water supply is safe for consumption. And this minuscule amount needs to be shared by the more than 7 billion people on the planet. And this water is not distributed evenly throughout the world. 1.2 billion people live in areas of water scarcity in places such as southwestern United States, India, Spain, North Africa, Australia, and northern China. At the same time, demand for water is. Over the last 100 years, global population has tripled and water consumption has increased sixfold. But our total water supply has remained unchanged. More people are now using a lot more of the same limited amount of water.
So I just wanted to give you an idea as to if we happen to use the low rolling resistant compound, what could we save? So I just took an obscure small country called Sri Lanka, and if we actually start using, and they have a very small distance to travel, truck population of under 500,000, and if we just assume half of them would be eligible to put this in place, and at 4% saving, we are looking to save about $50 million. Now, translate that into Europe. So these are things which can be, where you can actually measure. We have a gentleman talk about how we can do tire data measurement. This is very easy. You can actually measure the carbon footprint that you're going to save, the water footprint. It's going to be a game changer. I think the question I want to just leave with the audience at this point of time is, are we ready to so-called modify or recreate rolling resistance standard across the world? Because that will start reducing tailpipe emission. I mean, for instance, if I may just say, the EU is talking about microplastics in infield bans. That's very nice, but honestly, is that going to make a real impact? No. These are areas where they should be focusing on. Second is, from the rubber and tire industry. While we can say 2030, 2050, I can tell you by the time things move on, they will make it, 2,100 and say that's when we're going to be sustainable. They'll start pushing that. Will they voluntarily adopt these standards? And will EU as such, take the lead to saying that, can we have specifications for tire standards that is linked to casing reachability so that we actually move away from single-use tires and introduce a water tax in addition to a carbon tax and put regulations around that? Then you're going to have, more teeth behind the regulations. That's it. Thank you all for a patient listening.
Thank you very much, John and Brian. Are there any questions, please, before we finish? Krzysztof.
Thank you guys for a very nice presentation. As you've heard before, I'm not a big fan of silica and in rubber. That's why I just wanted to ask how much silica you can put in natural rubber with your solution.
The solution that we have on the books today would be about 4% level.
4%. Okay, we might survive then. Thank you.
Any other questions, please, before we finish? No, well, just before we do finish, just a couple of quick notes. The first thing to say is that we have been recording these sessions, and subject to the agreements of the participants, we will be able at some point to share a video of the of this seminar. And also, potentially the actual presentations themselves. We'll distribute those within the coming days and weeks. Second is to thank everybody for coming today, and especially those of you who stayed until the end. Now, we are going to have a break now. We finished a little bit early, so please go and have a drink and something to eat, enjoy yourselves, but please don't go away, because in 5:45 we are going to have the awards ceremony for the Recircle Awards, which is our awards programme to celebrate excellence in the tyre retreading and recycling industries, especially within the circular economy. And I know that there are a number of nominees present today, so please come along and support them. We're giving out 20 awards this evening, which means there's been approximately 80 companies and individuals nominated for these awards, and they're all very deserving of their nominations, so please come along and support them. So thanks very much for now, and enjoy your break. Thank you.